In this video we are going to discuss about the sequential logic circuits. So here in completion of this topic, students will be able to explain the combinational logic, and also they can explain the difference between the sequential and the combinational logic. So in combinational logic, that is first we can say about the sequential logic, that is it is the type of the logic circuit whose output depends on the present value of its input signals and on the sequence of the past inputs. So this sequential logic is used to construct finite state machines, a basic building blocks in digital circuitry, and also it is used with the channel up and channel down buttons. Also this can be divided into the synchronous as well as asynchronous types. So this combinational logic circuits, this lacks the capability of storing any previous events and non-regenerative circuit. So there is no feedback relationship between the output and the input. So output depends only on the current input and has no memory. And here in the sequential logic, this output depends only on the input but also on the past input values. That is, it is design a counter and it needs some type of memory to remember the past input values. So circuits that which you are learned so far can be the information that is storing on the circuits. So here you can see the inputs combinational circuit. Next state it is given to the storage elements. From that the output is given and it depends on the present stage. And here this sequential logic circuits remember the past that is sequential logic circuits remember past inputs and the past circuit state, and outputs from the system are the feed as the new inputs with gate delay and wire delay. So the storage elements are the elements that are capable of storing binary information, that is memory. And also this nearly all the sequential logic today, it is a clocked or synchronous logic. In the synchronous circuits, an electronic oscillator called a clock generates a sequence of repetitive pulses which we call it as clock signal. That is, it distributes to all the memory elements in the circuit, and also the basic memory element in the synchronous logic is the flip-flop. The major advantages is its simplicity, and the logic gates which perform the operations on the data require finite amount of time to respond to changes to their inputs, that we call it as delay. Also the interval between the clock pulses must be long enough so that all the gates have the time to respond to changes and their outputs have to settle to stable logic gates before this next clock pulse occur. So as long as this condition is met, the current or the circuit is guaranteed to be stable or reliable. And synchronous, you can see the difference between the synchronous and the asynchronous. So synchronous has two main disadvantages. Actually the main disadvantage, possible clock rate is determined by the slowest logic path in the circuit, otherwise known as critical path. Every logical calculation from the simplest to the most complex must complete in one cycle. So logic path that complete their calculation quickly are same most of the time, that is waiting for the next clock pulse. So this synchronous logic can be slower than compared to the asynchronous logic. One way to speed up the synchronous circuits is to split this complex operations into several simple operations which can be performed in the successive clock cycles, so that we can call in the other name as pipelining. And in the case of the asynchronous logic, it is more difficult to design and subject to the problems that is encountered in the synchronous design. The main problem is that digital memory elements are sensitive to, in order that their input signals arrive. If the two signals arrive at the flip-flops or latch, it is almost same. So the circuits goes into, and it can depend on which signal gets to the gateless. So that we call it, that can be goes to the wrong state also. So this is the major difference between the asynchronous. And in the synchronous sequential circuits, the flip-flops can receive their inputs from the combinational logic circuit and also from the clock signal with the pulses at fixed intervals. Quiz questions on the synchronous logic circuits, difference between synchronous and asynchronous logic circuits. Thank you.